Okay, so on yesterday's quick little notes and assignment, we learned the names of the polygons and if they are concave, convex, regular, or irregular. So, number one, we got to count these sides. So 1, 2, 3, 4, 5. What do we call a five-sided figure? Pentagon. So y'all got to be familiar with that word, right? Pentagon. Okay, pentagon. And then, this is a vocab word from yesterday. Is everyone hearing me with their head up? We want to know, is it concave or convex? Concave does what? Goes inwards. So it's in the name. It caves in. So concave, one of those vertices will point inward. Do that. Potential. Do that. All right. So concave caves in, and this vertex right here is pointing inwards. Caves in. So concave. All right. And then regular or irregular. Now, what does regular mean about the sides? The sides are all congruent, and the angles are all congruent. Now you tell me, does that look regular? Irregular, thank you. So, everybody, not all the sides are the same. And by the way, if it's concave, it cannot be regular, okay? Because that angle doesn't match the other angles, okay, when it caves in. So this is irregular. Okay, number two. If you can't count them, I put it on there. How many sides is that? 7 sides. Now, what do we call a 7-sided figure? And if you're not sure, besides Google, okay, the notes I gave you yesterday have it, but it's heptagon. H-E-P-T. Heptagon. Cool? Don't mean to spit. Hept. Kind of makes you. Well, anyways, heptagon. Let's write that down. Is everyone going to memorize that word? Again, if you're just passively watching me do this, you're going to need to actually think about this for a few seconds to memorize heptagon is 7. So, is this concave or convex? Okay, every corner is pointing outward. None of them point inward. So it's not caving in, it's convex. Write that down, convex. And just by looking at it, do your best estimate. Do you think that's regular or irregular? Every side looks the same. Every angle looks the same. That is regular, okay? Now, right now you're just kind of guessing at it, but if I put like all these tick marks, you would know, hey, those are all congruent. And if I put all these arc marks, you would know, hey, those are all congruent. And then you know for sure, regular, okay? So, number 3 looks like a lopsided potato. Pointy potato. Okay, 9 sides. What do you call a 9-sided figure? Everyone else, y'all with me? 9-sided is non-agon. Again, it's in your notes. So 9, non, 9. And again, this little sheet you got yesterday, packet, all the names right here besides 11. What's an 11-sided figure again? Who remembers? Untitled. 12 is Dodecagon. Okay? So, but this 9-sided figure is a non-agon. What do y'all think? Concave or convex? Convex. Every corner is pointing outwards. It's not caving in. Convex. And is it regular or irregular? Okay. Not every side is the same. You can tell because it's kind of weird shaped and stretched out and whatever. So, irregular. Now, if you could do this warm-up, then you can definitely do yesterday's assignment in probably 5 or less minutes. Okay, make sure you've turned in Intro to Polygons when you can. You might have some time today after the notes, but like I said, notes. So let me pass these out. All right, so, okay. All right, so just like the warm-up, I want you to, let's see if you can beat a minute. Excuse me. You have something to do right there, don't you? Thank you. Now, on the left side, I want you to name all of these shapes that are in the second column, okay? I'll give you a minute, see if you can beat a minute. Let's do it. First one is an easy one. What's this called? Triangle. Write it down. And do the second one. Hint, the second one, don't put rectangle. What do you call all four-sided figures? Starts with a Q. Quadrilateral. Yeah. Keep going. All right, so we already said the first one was triangle. Second one we said was, if you put rectangle, technically this picture is a rectangle, most likely, but we want to put quadrilateral for all four-sided figures. Kind of a long word. Okay, this next one is five-sided, so Pentagon, like the warm-up today. Are we good with pentagons by now? Five-sided? Okay, six-sided. Yeah. Six has an X. Hex has an X. You think X? Hex. Six. Okay, here's that weird one from the warm-up. What do you call a seven-sided figure? Heptagon. And then, last but not least, eight-sided octagon. That's where you don't want to find me, you know? Thanks. It was a good joke. Now, next column. This is super easy. How many sides do these have? Okay. So 3, quadrilateral is 4, pentagon is 5. Y'all can probably beat me to the bottom of this page, right? Okay, 7, 8. Whoops. What did I do? Yeah, don't write what I write. All right, 6, 7, and 8. Sorry. Hexagon is 6, heptagon is 7, octagon is 8. We'll get to the last one later, but that's good to start with. Now, this is not a trick question. So don't be like first period and get tricked. Ready? In this triangle, how many triangles are there? 1. I know it's profound, okay? But there's one triangle in that one triangle, okay? Kind of duh. You see one triangle? That's one triangle, right? Now here's the question. How many degrees are in that one triangle? 180, right? We learned that already. So basically, 1 times 180. Oh my gosh, hold on. Back it up. Check it out. On the rest of these, we need to do what are called, or we need to draw what are called diagonals, okay, which connect a vertex to another vertex. Here's what you do. Pick one corner, put a point there, right? Please and thank you. So pick this corner. Actually, it doesn't matter which one. And draw as many diagonals as you can from that one vertex, okay? So I can only draw one diagonal. So when I draw that one diagonal, it cuts it into triangles. How many triangles do I have there? 2, okay? Now here's the question. How many degrees are inside of a 4-sided figure? You may or may not know. But here's how you can find out. If you know there's 2 triangles, and each of those is 180, it's going to be 2 times 180. So that's why over here, I'm going to take that number of sides times the triangle of 180. What's 2 times 180? 360, okay? Cool. Let's do it again. 5-sided figure. Pick one vertex, put a point there, and make your diagonals. I can make 1, 2, that's it. Don't start at another vertex. I don't want them overlapping. While we're at it, let's just do the rest of these diagonals, okay? So pick one vertex and draw all your diagonals that you can. How many can I do here? It's a little too curved. Whatever. Well, on a hexagon, I can make 4 triangles. I know there's 3 segments, but they make 4 triangles, right? It doesn't matter where you start. Make your diagonals. All right. So you can cut each polygon into triangles. So let's write these down. How many triangles did I get on a pentagon? 3. I know there's 2 dividers. That makes 3 triangles. How many triangles on a hexagon? 4 triangles. 1, 2, 3, 4, 5 for a heptagon. And then 6. They might be kind of skinny and weird, but those are still triangles. 6 triangles. Now, off to the right, all we're doing is taking the number of triangles times 180, right? So what do I write here? 3 triangles times 180 is what? 540? So again, hexagon, 4 triangles times 180 is what? 720. And again, all this stuff you can get on your calculator. Okay. 5 triangles times 180, 900. And then octagon, 6 triangles are made times 180, 1080. Now, y'all know I turned extra old on Thursday, but back when I was in middle school, on the N64, there was a new game called 1080. It was a snowboarding game. You were trying to do 3 360s. Well, anyways, real game. Google it. All right, now, at the bottom, number of sides is n. So what am I going to put right here underneath number of sides? N. If the number of sides are n, and it asks me the number of sides, it's still n, right? So no matter what the number is, here's my n. Now y'all are smart. You can tell me. The one right next to it So, what's the difference between the sides and the triangles all the way down here? What do you notice between these 2 numbers all the way down? What? They're in order. What else? What do I do to this number to get this number? minus 2, all the way down. Does everyone see that? 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. Sorry. 6 minus 2 is 4, all the way down. So, take a wild guess. If everything has been minus 2 all the way down, what am I going to put right here? Whatever n is, minus 2. So go ahead and put that, n minus 2. Cool. Now, last step, bottom right. Okay. What did I do with that number of sides? Okay, I subtracted 2 to get the triangles. What did I do with those triangles to get the degrees? Times 180, right? Now, it's not just n, it's this thing times 180. So at that bottom, this is the most important thing for today. This is what we are discovering. Is that to figure out the sum, you take the sides minus 2 times 180. Box that in because that's important. N minus 2 times 180. And you can flip it over and write that at the top of the next page because it's asking you what's the theorem. What do? Well, n minus 2 times 180. So flip it over, write it down again at the top. In that box, that rectangle. We good to flip it? So right here at the top, the polygon sum conjecture. And write the word interior. Today we've only talked about the inside. So for the interior angles, if you see this key word, sum, if you see sum, you're going to use n minus 2 times 180. Okay? The number of sides minus 2 times 180. So look at these reflection questions. What's it asking? What's the measure of the sum of the interior? That's what it says right here. So I'm going to use that formula we just figured out, okay? So let's do it on these 3 examples real quick, right? No distractions, right? Right? If you're looking at a phone, right? Put that away. Now, a 35-gon has how many sides? 35. And you know it says sum of interior, so you know you're going to use this formula right here. So let's plug it in. What's n for a 35-gon? 35. So it'll be 35 minus 2 times 180. Okay. Number of sides, take away 2 times 180. And my suggestion, I know you can subtract 2 in your brain, hopefully, and then you can times it by 180. But whatever, I'll just type it in one step. 35 times 2 times 180 is 5940. Now that's a lot of degrees, but the more sides you get, the more degrees are inside the triangle, okay? Number 2, dodecagon. How many sides is a dodecagon? What do you think, dodecagon? Is it 11 or 12? Wrong. 11 is un, like uno, more than 10. Dodecagon is like dos, more than 10. All right, so dodecagon is 12. So I'm going to plug in 12 minus 2 times 180, right? Let's write that in. 12 minus 2 times 180. And again, type it in, you get 1800, the year I was born. I know, that's got good genes. All right, next one. 125-gon has how many sides? It's in the name, right? So what am I going to write? You don't know? 125 minus 2 times 180. That's times. So what is 125 minus 2 times 180? 22,140. That's the year I'm going to pass away. That's a lot of years. All right. I know. I got all the math that I know will keep me alive. And you too, right? Math power. Now, that's for the sum. You all know sum means total inside? Now, sometimes they're going to ask you for this. Is everyone looking right here? Second thing you got to know today. What if they ask you for each interior of a polygon? Sorry, regular polygon. So what does that mean? instead of saying what do they all add up to, they're asking you for just one. So it'll either say each or one or an interior angle. That just means give me one of them, right? So you tell me, if this formula gives me the total, if this gives me the total, what do I do with the total to get one of them? If I know all the angles add up to some number, I need to divide it into however many sides there are, right? However many angles. So again, to find each, take that formula from above. Here's my sum. And then we have to divide by the number of sides. Okay? That fraction is kind of ugly, but that's how you get each interior or one interior. Okay? So guess what? People sometimes don't read their problems and they just guess which one to use. Well, you just look for the words. If you see sum, boom. First one. If you see each or one interior of a regular polygon, boom, use that one. Okay? Now down here there's some typos. These letters don't belong here, so yeah, pretend like those don't exist. All right, now, what do you know about the sides of a regular decagon? They're congruent. Right? And you know how to mark that on here? And all the angles, well, those are also congruent. It's a lot of writing, a lot of notation here. Okay, so what is the measure of each interior? Well, we already wrote this down once. You can write it again if you want. We're going to do one example of this together instead of having to do overkill, like 3 of them. But look at example 2. What is the measure of what? Each. Oh my gosh, I have to use the new formula, right? Interior, only if it's regular. How many sides is a 25 gone? 25. So please write small, because I know there's not a lot of room here. But we're going to plug 25 into this formula up here. So instead of n, 25 minus 2 times 180. And I have to do what different? Divide by 25. Now, did you know you can just type that in one step, get your answer? But it only works if you know which formula to use, right? All right, so let's type it in. 25 minus 2 times 180 is... Now, if you get a fraction, y'all know you can press Control, Enter. It'll give you the decimal, and we get 165.6. And that's each angle, so make sure you mark it in degrees. Okay. Now I got one challenging problem to show you, and we're done with the notes. Okay. Now look at this. They want us to find angle E. If it's missing, you can put an X there. Cool. We did something like this. You want to put an X there? We did something like this with triangles, and you know, triangles add up to 180, so that was easy, right? But here's my question. What is this 5-sided figure? 1, 2, 3, 4, 5. What is this 5-sided figure going to add up to? How many degrees? That's a triangle. This is a 5-sided figure. So we learned today how to figure it out. What formula will give me I need to find the sum first. First step, find the sum of the interior, okay? That's your first step. And at the top of this page, didn't we write down the sum of the interior formula? Which is n minus 2 times 180. What is n for this figure? How many sides? Does everyone agree we got 5 sides, right? So don't assume it's 180, okay? We have to plug in 5 into that formula, okay? So 5 minus 2 times 180. And y'all know where I got 5 from. I counted the number of sides. So 5 minus 2 times 180. What do I get? What'd you say? Okay. So we plug it in, get 540. So now that I know that these 5 angles add up to 540, now I can figure out x. Okay? But I'm telling you, some people get ahead of themselves. They want to start working it out. You can't set up an equation unless you know what it adds up to. So you got to figure that out first, okay? What if it was a 6-sided figure? It's not 540 anymore, right? You use that formula. Now, I'm going to set this up as an equation. I'm going to add all 5 angles equals 540, okay? So start here. 81 plus 108 plus 135 plus 81 plus x equals the total of 540. Okay? Why do you only pick up your head when I come over here? Keep your head up. So, first step, all these like terms, I'm going to combine like terms. I need to add up 81 plus 108 plus 135 plus 81, which I did, and I got 405. Bring down plus x equals 540. What's my last step? Subtract 405 from both sides to get x by itself. What is 540 minus 405? 135. That means that missing x is 135 degrees. And it's not just because C was. They're not always going to be mirroring like that. They're not always isosceles or anything. Okay? You got to figure it out using this method. It depends on the number of sides. So please be careful if you see a problem like that. Now, today's assignment doesn't have one like that. Okay? This one's pretty straightforward. Can you find the sum of the interior using n minus 2 times 180? And then on the back, it's asking you for each interior, which is n minus 2 times 180 divided by n. Okay? It says, please read the instructions. It tells you which formula to use if you look at your notes. By the way, if you didn't finish yesterday's Intro to Polygons assignment, you could probably finish that in less than 5 minutes first, and then you can probably knock this one out before you leave. Okay, this intro stuff is not too bad. Okay, so let's do that now, please.